Howdy, all. I'm Professor Perks, PhD, and I make content on astronomy, science skepticism, and mental health. I apologize for those of you who are currently watching. Sorry about that. Yeah, it's been a tech kind of nightmare tonight. It kind of started with my original plans, which were to actually work with the telescope tonight, but yeah, the weather is not cooperative. So I figured if I couldn't work with the telescope, then I'd spend an hour or so with y'all. Because a couple things have just popped up that I just kind of wanted to chat about. And I have to say that, not that you should feel honored, but I hate overhead lights. So the fact that I've had them on kind of tells you that the lighting situation in my office, when it comes to live streaming, needs to be improved. Because, yeah, I hate fluorescent lighting. Anyway, where should we go from here? Where do we go here? So, yeah. Howdy, all, Clive. Stephanie, thank you for coming back. Georg. We got PhD Tony in the house. And do we have a Judy? I don't know if I saw Judy. We definitely have a Curse Durham. Howdy. I think that's it. I think I saw a couple of other people. Peyton, how are you? Hope you all are doing well. As I said, I am originally was planning on doing some telescope maintenance tonight, but sadly the weather didn't cooperate. I have been absent off the tubes and away from Discord and such, mainly because of just life, health, and other reasons. So, but yeah, I'm struggling to come back. Clive, you do definitely have a large teaching load. One of the things that I am thankful for this semester is that my teaching load is not nearly as great as it is in fall. So hopefully I'll have more time to devote to YouTube and making content, not only just these live streams, but also some edited content as well. Yeah, somebody gave me an excellent idea for content. I think it was Stephanie. But for the life of me, because I think my dementia is kicking in early, I don't remember what that content is. Hopefully I wrote it down somewhere. So if you learn nothing from the stream, learn this. No love, no tacos. It is a mantra to live by. So what am I going to talk about today? Well, or tonight, or what have you. As the title says, is the Vatican Telescope named Lucifer in all capital letters? This is something I've been hearing among the flat Earth community for years now. It every so often it pops its head up. People don't make a huge thing of it, but they pop it up to basically, usually to slander the Catholic Church. And there are plenty of reasons to slander the Catholic Church. You don't really need to start inventing them. So I just kind of wanted to go over that and also talk about how instruments are named, how astronomy goes about naming its telescope facilities and its instruments, just so people will know. History of astronomy, but I thought there was something more specific about it that I wanted to talk about. So I will talk about the Vatican Telescope, or rather the instrument that is now referred to as Lucy, and what that little controversy was, I think about a decade ago at this point. I'll also make some mentions on A Brief History of Black Holes by Dr. Becky Smethurst. I actually have never heard her last name pronounced, so hopefully I got that right. Smethurst. Dr. Becky Smethurst, otherwise known as Dr. Becky on YouTube. I just got this. I loves me some Dr. Becky. So I subbed to her channel, and definitely keeps me updated on the JWST observations with respect to cosmology. And I still love her, even though she She refused to provide us with a public talk here at George Mason because apparently 11 p.m. her time is too late to give a public talk. So obviously she's a theorist, because if she were an observationalist, 11 p.m., that's the start of your day. So, but yeah, Dr. Becky, highly recommend her channel. I picked up her book, been meaning to for a while, and I just picked it up, and I just started it today. So I'm only a couple chapters in at this point. And I wanted to give my thoughts on that. Maybe I'll start doing that as a regular segment of these live stream ramblings, is giving reviews on books. At this point, instead of reading a book straight through, I am now reading about, at this point, 4 or 5 books, a chapter a day. I find it to be more economical, and hopefully it'll help me recall the information better. I've been thinking of models versus reality. Tony says, I've been thinking of models versus reality. I wonder if you could at some point discuss how to work out how much daylight, nighttime occurs on a given day. Yes, I can do that. I'm assuming you mean on the globe, because one of the things that AB Science has done, actually, has he? He did a lot of, and I think Bislin did this as well. It's been done a couple of times where they actually have looked at what the day and nighttime cycle would be with certain assumptions in the flat Earth model. But yeah, I would definitely be able to go into how, or say something about how daytime, nighttime works. And if we really wanted to get into it, we really need to actually talk about atmospheric refraction, because that is something that needs to be taken into account in terms of what we consider daytime and nighttime, because there are, at least in the States, we have 3 different we have 4 different times at the beginning and the end of the night, or beginning and the end of a day. So the first is sunrise, or the first is civil twilight. Nope. I am just all over the place tonight. The first is astronomical twilight. Astronomical twilight is, I can't remember how specifically it's defined, but basically astronomical twilight denotes when the sky is bright enough that basically the faintest stars are no longer seen because of the daytime sky. So it is the first thing to happen during sunrise, and it is the last thing to happen during the sunset, before the onset of day and the onset of night. The other one is nautical twilight. So you have astronomical twilight, you have nautical twilight. Honestly, I have no idea why that's different from astronomical. And then you have civil twilight. And civil twilight is, I've seen defined as essentially the time of day or time of night where headlights are required. So if you are driving after civil twilight or before civil twilight, if you're talking about the morning, then you're legally obligated to have your headlights on. And then, of course, there is the physical sunset, when the sun goes below or above the horizon. So the refraction correction is about 0.3 degrees extra. I think so. It's been a while since I've actually looked into that. But yeah, I can definitely, let me write that down. Definitely say something about that. Model reality. I did also, kind of along those lines, I also did, and maybe this is what I was thinking of, is I wanted to talk about atmospheric refraction in terms of astronomy, because for whatever reason, professionally, I've dealt with astronomical refraction all the time. However, I don't really think of it as that exactly, or at least I don't think of it in the terms of, seeing too far or things of that nature. For me, the problem with atmospheric refraction is that it blurs out images, and so you need to do things to compensate for it. The one thing that I'm thinking of is the most robust, and that is what's called adaptive optics. And that's really only done on the large research grade telescopes at this point. It's now a standard feature, but it's not something that you can really do very well from, like, for example, our 32-inch telescope. We could not put in an adaptive optic system on this telescope. We could try to put in what's called an active optics system, which would attempt to mitigate some of the problems, but we certainly can't get rid of it. So I was thinking of actually talking about atmospheric refraction in terms of astronomical observations, and as a sort of in part effort to talk about or prove to certain folks that atmospheric refraction is a thing. Giant world crushing, space laser. Gary. Oh yes, Gary. The Wybanga. Yes, that would be. Woo! I would be honored to have Mr. Wybanga assist me in any sort of discussion of atmospheric refraction. And that is all the sarcasm that I am going to merit on that he merits on that subject. Anyway, so where was I going? Evening, Charlie Wells. So one of the other things I want to talk about was a little bit of mental health. I won't go too far into the subject, but a couple of I've been asked again more recently why I talk about mental health, particularly my own mental health, and I just want to reiterate that I do it because one, it's I use it primarily as a coping mechanism. If I talk about these things openly, then I feel unburdened, as it were. Someone brought up an interesting point of, by doing so, am I putting darkness into the world? Am I bringing people down effectively? And that has occurred to me, and I don't know. It hasn't prevented me from continuing it, because I think the benefit of talking about it openly is outweighs the darkness. Because I think, honestly, if we're going to get rid of the stigma on mental health, then we need to start having open and honest conversations about it. And when it comes to mental health, I think those conversations can only come from a personal level. I believe that I can't come on here and basically tell you how to live your life. All I can do is, it's going to be self-centered. I can tell you what has worked for me, what has not, and go from there. And I think, like I said, I think the world would benefit if that discussions of mental health, particularly people's mental health, it would be more of a commonplace thing than it is now. Which reminds me of something, which may or may not relate it, because I'm getting conflicting information about it. But all I will say right now is Triggered Limey is recovering. For those of you who are not aware, Limey he's in the hospital. He was in a coma. He was not doing well at all. But he put a video out today that from his hospital bed, basically saying that he's recovering. He should stop doing that, because he apparently tore out his what is it? He's getting dialysis, so he ripped out a tube, and blood was everywhere. So, Limey, if you see this, or if anyone who knows Limey, please tell him just to stop updating us with videos until he is actually back up on his feet. So much love to Limey, and I hope that his recovery continues. One conversation that I might have at some point outside the stream is that I've just started chatting with a woman, Hopefully things will go well with that. She actually knows about my YouTube channel, so if she happens to be watching, howdy. But you brought up the question of when in a relationship, either a friendship or more specifically something that you hope to get more intimate than a friendship, is when you bring out the baggage of mental illness. And I suppose this also happens to be is applicable to other physical ailments, but obviously mental health does have its stigma attached to it. So, when is the best time? Do you want to drop all that shit on the first date, or do you want to basically kind of slow roll her into it, or slow roll the person into it? Myself, I tend to be very upfront about it, because the only good part of the series Picard was the concept of radical honesty, although I don't practice it nearly as extremely as they do. The idea of just being open and upfront and honest as you possibly can, even if it is verging on TMI. I think of it kind of early. I would agree. I would agree. But again, that's something I would like to dive into on a different stream. So let's talk about, now what I wanted to do, go away. Okay, that was weird. Let's see. My computer's booted back up. Here it is, getting the tab open. So let's talk about the Vatican. For those of you who are not in the know, the Vatican actually has an observatory. Or more specifically, well, it has an observatory, and it has an observatory that has been around for a long period of time, for hundreds of years. That might actually surprise a few people, that considering the church's history when it comes to astronomical figures, for at the very least, it has not been a good relationship. But there was the previous director, and I think I mentioned this in the chats before I could go live. I was in the comment section of my own video, or the chat of my own video, and the former observatory director, Father Coyne, I was privileged enough to actually hear him speak on the very subject of the dynamic or relationship between science and religion, and his viewpoints were kind of the cornerstones of how I look at these things. I have never been able to verify this, but he claims that Galileo said that the Bible should be taken, I don't know if literally, but the Bible should be believed so long as it doesn't contradict what science tells us. And yeah, I generally, in a 5-second sort of summary, that's essentially what I had to say. But anyway, the Vatican Observatory, the controversy in question is, people have claimed that the telescope at the Vatican Observatory was named LUCIFER, and now it's not because of the backlash. Well, that's really kind of wrong on a lot of levels. For one thing, the Vatican Observatory is located in Italy, as you might expect. The telescope that we're talking about is actually the VAT, which is a 1.8 meter Vatican Advanced Technology Telescope, and it is on Mount Graham in southeast Arizona. It is operated by the Vatican Observatory, but it is not actually at the Vatican Observatory. I know that might seem like it's nitpicking, but it definitely is a point to be made, because it also tells you something about, because this also goes into how astronomical telescopes and science instruments are kind of clustered. So let's start off with that part of it. So for optical telescopes, I was going to say optical interferometry because I've got that on my mind, but for optical telescopes, or telescopes that look at the wavelengths our human eyes can perceive generally, then there are certain conditions that are most favorable for doing those observations. If you're going to spend the money to build a 1.8 meter telescope, which I'm assuming at the time when it was built, that's kind of a pretty good chunk of change. You don't want to build it in a place where your images based on the atmosphere and the location are not going to be optimal. Like, you would not build this thing here, for example, or Florida, for example, for a number of different reasons. So when it comes to optical telescopes, this is different from radio telescopes and slightly different for infrared telescopes. An optical telescope needs a few things. One, you want it to be isolated. You want it to be away from as much light pollution as you can possibly get, although that's becoming harder and harder with every year as light pollution becomes more and more ubiquitous across at least the United States. I'm going to go so far as to say the globe. And yes, I know, I just said globe. So you want it to be isolated, for one. You want it to be dry. Yes, Tony. You want it to be dry. Basically, what you want, more specifically, is the way you get it to be dry is you want it to be as high up as possible. You literally want to look through as little atmosphere as you possibly can. Because one of the major contributors to atmospheric refraction is water vapor, or at least in terms of astronomical or imaging, the effect that causes the image to blur out. That a lot of that is due to water vapor. So if you can get above the water vapor, you are great. A prime example of this is if you happen to live in California or planning on visiting the LA area anytime soon, highly recommend you go up to Mount Wilson. Mount Wilson is just north of Pasadena. It's in the San Gabriel Mountains. It is a historic observatory. Now, you want to do this at night, and there are a lot of little side park overlooks, as it were. You could have a little romantic interlude if you want, or do whatever. So you don't need to be on the site itself, but just up on the mountain. And Mount Wilson is historic because it is one of the best observing sites in the world, or at least it used to be. It is no longer isolated, so therefore it is very, very limited in terms of its brightness. So the 100-inch, unfortunately named Hooker telescope, is no longer in use because it's the depth of field that it could see, the brightness limit at which it could potentially reach, it can't because of the sky brightness. But interferometry can be done up there because interferometry by its own nature is light limited. So the light of the sky brightness actually is not a limiting factor when it comes to optical interferometry. But I digress. The reason why it is one of the premier sites is because of the fact that it's just above the marine layer. So if you go to Mount Wilson, and you go onto the mountain at night, the thing that always struck me whenever I was out there is you look up, stars really don't twinkle at all. They are as rock steady as I've ever seen them anywhere else. However, if you look at the city and all of those low pressure sodium lights, these orangey sodium lights, they twinkle like mad. They are just twinkling all over the place because 5,500 feet at that point is just above this layer in the atmosphere where a lot of the water vapor, and particularly smog, gets trapped. And so that atmospheric refraction is actually flipped. When you look down, you're actually seeing the lights go nuts. I have a couple of pictures of it, but I really wish at the time, well, I didn't have a cell phone at the time that actually could take quality video or even video as were. So it's been a while, but if I ever go back, I'm definitely going to take a video of it. So you want it above as much water vapor as you possibly can, which is often the reason why telescopes are on mountains, is because of that. The other reason, and this is another reason why Mount Wilson is such a good site, is that it's not that you want the air to be still. Because really what's happening with this refraction is you can think of the atmosphere as being comprised of many different little tiny pockets of air. And those little tiny pockets of air all have varying indices of refraction due to temperature, density, composition, things of that nature. And so when the light passes through each of those tiny little pockets of air, different pockets of air, the light is going to refract, because light refracts as it goes from one medium with an index of refraction to when it passes from one index or one medium with an index of refraction into another medium with a different index of refraction. And these are tiny little cells, as we refer to them as, or at least small cells, as we refer to it. And so, as I like to say, it plinkos its way down. The light will constantly being kind of reflected or refracted around like it's being hit by a whole bunch of different mirrors all the way down. And that one complication of this is those cells, that's not static. Those cells move around. And so naively, you might want to say that you want a site that has no wind. You want a site where the cells are not moving at all. And that is true. A windy or windless night is most optimal. But if you're going to have wind, because wind is a thing, you want your wind to be what we refer to as laminar and not turbulent. For all you smokers out there, you are familiar with what this looks like. A laminar flow is when the air travels essentially in straight lines. So if you have your cigarette, the smoke that's coming off the cherry is coming up pretty straight as it comes up. And that's what we refer to as a laminar flow. But eventually it's going to, because of the interaction with the atmosphere around it, it's going to get all kinds of it turns into a cloud, gets turbulent. So what that means is a laminar flow is going to allow these cells to travel through your line of sight more coherently than a turbulent flow. A turbulent flow is going to cause those cells to be mixed with a lot with more rapidity, if that's a word. Your cells are going to be moving around. Your refraction is just going to be worse. It's just going to be, the cells are moving around fairly chaotically. So if you look at a map of the LA basin, what you notice is you got the Pacific Ocean on the left side, and then obviously you got the rest of California on the right side. And what we find is that airflow coming off of an ocean is laminar, but as soon as it hits a mountain range of any sort, then it becomes turbulent. So that's one of the better places to put it. And again, you can see this with Mauna Kea in Hawaii, which is the American premier observing site. And you can also see this with the Europeans, who love to put their telescopes in the Andes Mountains. Again, you have the air coming off the Pacific. It's laminar in nature, but becomes turbulent once it passes over the mountains. So in Mount Wilson, it's the San Gabriels. In Chile, it's the Andes, and then on Mauna Kea, it's Mauna Kea itself. So you want the telescope to be isolated. You want the telescope to be high up. You want the telescope to be basically right next to a mountain or windward of a mountain. And and you want it to be clear. you want it to be dry, but more specifically, you want the cloud coverage to be minimum, which again gets mitigated almost entirely if you are on the mountain or on the Andes in Cerro or in Mauna Kea, because you are well above the cloud layers, even the high altitude clouds. I've never heard of Mauna Kea being clouded out. So, all that being said, when it comes to research grade telescopes, you have there are select spots that people tend to congregate. There are people who go out when you're thinking of building a new telescope. You will then send people out to analyze certain sites, and they will go to the go-tos first. and they will see what the seeing conditions are like at that site in the present epoch. And they will also ask questions like, is there room for another telescope at this facility? If the answer is no, then they move on to find somewhere else. But usually what they'll do is, like I said, they'll cluster these things. I have thought about that, although they don't spell it right, and they are radio astronomers, so dirty, dirty cheaters. But I have thought about it. Actually, what I've thought about is building my own Parkes Observatory and becoming so famous that no one even knows about the one in Australia. The positional errors. What sort of positional error might refraction occur? So the answer to that question is you have this thing called, for those who don't might not know, you have a diffraction limit. The actual application for Rayleigh's criterion. Rayleigh's criterion states that based on the size of your collecting instrument, either a lens for a refracting telescope or a mirror for a reflecting telescope, based on that size and based on the wavelength of light that you are observing, you have a minimum angle of resolution where you can legitimately distinguish two objects as being two separate objects rather than as one kind of amorphous blob. The larger the telescope, so that is one of the reasons why bigger is better, is the larger the telescope, the smaller that angular resolution is, that diffraction limit is. However, because of the nature of the atmosphere, once you get above 10 centimeters, it doesn't matter what your diffraction limit is. You are entirely at the whim of your local atmosphere. So, for example, the Keck telescope on Mauna Kea, which is a 10-meter telescope, from my understanding, has a diffraction limit of 0.25 arc seconds, meaning that it can tell the position of something in the sky relative to something else with an accuracy or with a precision of 0.25 arc seconds. To give you, again, a sense of scale, the full moon is 30 arc minutes in size. Take one slice the moon into 30 equal width slices. One slice is an arc minute. Slice that into 60 equal parts. That slice is an arc second. And so if you take that slice and you split it into fourths, that would be the precision of the Keck telescope from a diffraction limit standpoint. However, atmosphere is nowhere near going to get you there. Like, for example, with our site, which Mauna Kea would be better, but our site, our limit, our good night is about 3 arc seconds, thereabout, and that's a good night. Typically, it's on the order of around 4 arc seconds, meaning that we cannot differentiate two objects that are closer than 4 arc seconds away from each other, or we cannot determine the exact position of something with any more precision than 4 arc seconds. So, yes. And that might not sound like a lot. Arc seconds are really tiny, but considering that we are getting into the age of astronomy where things like parallax, trigonometric parallax, you need precisions of milliarc seconds, then a couple of arc seconds is not going to get you there in any way. The project that I hope to do with some high school students by looking at observational lens objects, it's going to really push what we can do here. Because those are basically comparable. The lenses, the images from the lens are separated on the order of our error. So I'm hoping, so the best that we could possibly get is a partially resolved image. And I'm hoping that will be sufficient enough for us to be able to say something about those positions. Yes, another one of the Wybanga's expert issues. Along those lines, Rayleigh criterion has nothing to say about how things disappear in what direction. It also has nothing to say about detectability. I'm going off in a tangent, but why not? It's shouting into the void. I always go off in tangents. So let's talk a little bit about the difference between resolvability and detectability. Resolvability is the ability, as I've said, to differentiate two objects as two separate objects. Detectability is the ability to detect something, to see it at all. Think of an eye chart. If you have poor vision, then you will be able to resolve part of the eye chart, but the smaller letters you will not be able to resolve. But you can detect the whole thing. Even the fuzzy bits at the bottom, fuzzy letters at the bottom, you can see the fuzzy bits. You just can't read them. You just can't see them at all. And so this idea that the Rayleigh criterion is a measure of how far you can see is not accurate at all. The detectability depends on the power of the source and its distance. If you've got a star that is a nuclear powerhouse putting out, what is it? 10 to the, I'm going to get this wrong, like 10 to the 30th joules per second, I think is at least close to what the solar luminosity is. When you've got a ginormous ball of nuclear energy burning in the sky, you can see that from it at distances of millions, even billions of light years. Because there's so much light there, you can't see. Can you resolve it? No. We can, at this point, most of the stars in the Andromeda Galaxy, the closest star, the closest galaxy to us, no, we cannot actually individually resolve the individual stars. It very much looks like how the Milky Way looks to us. The Milky Way, when it's across the sky, in reality, you are seeing millions upon millions of stars. But your eye is insufficient to be able to resolve them as stars. So it all just kind of looks like a fuzzy patch, a fuzzy arc across the sky, cloud-like. You look at galaxies, images of galaxies, they look like fuzzy objects, literally disks. There are certain points of light that you can distinguish. Those are not stars. Those are, in fact, depending on the galaxy, those aren't stars. Those are, in fact, active star-forming regions, so usually giant molecular clouds. In Andromeda, you can resolve some of the stars that are in the halo. So we have been able to do Cepheid distance measurements on those particular stars, but in general, no. So there is a drastic difference between resolvability. Oh, howdy, Bloodhole. Haven't seen you in an age. Hope you and your family are doing well. So there's a vast difference between being able to resolve something clearly as a particular or a set of objects and to be able to see them at all. So we cannot resolve the Andromeda Galaxy as individual stars, but we can certainly see the light coming off of it. So when it comes to getting back to the Vatican, so the Vatican commissioned the Vatican Advanced Technology Telescope, otherwise known as VAT, V-A-T-T, capital V-A-T-T. Then, a little bit later, there was an instrument known as the LBT, Large Binocular Telescope. And as you might think, it is two, 8.4 meter telescopes that are sitting right next to each other. And they act as an interferometer. I don't know. I would imagine they can look through one mirror at a time, or they can use it as an interferometer. I've never used the instrument, so I'm not entirely certain. Other interferometers, like the Keck interferometer, could be used in either mode. The European VLTI can be used either the individual UTs, as they're call it the unit telescopes, the 8 meters. They can be used individually or part as an array. But anyway, the LBT is the culprit here. But before I say that, thank you, Indie Tiger, for the $10 super chat. As a segue, my channel is now monetized, at least for memberships, super chats, super thanks, any support in that region, greatly appreciated. Bellywood is my first channel member at the Mercurian level. So if you're interested in supporting the channel that way, please please have a gander at it under memberships. I do also want to shout out at this point my patrons. Those are Judy Bassett, Indie Tiger, and Dora Naku, and they support me that way. And the ticker that I've got down there is talking about the patron. But anyway, what does he have to say? When my eye doctor asked me to read the letter chart, I say, sure, doc, bring it in. Very nice. Yeah, I am getting to the point where my reading glasses are no longer going to be, I'm going to need glasses that are no longer just reading glasses. So, yeah, it's going to be great. Anyway. So yeah, the LBT. What about Lucifer? Well, oh, and by the way, I know of this, but I hadn't really looked into it in a long time. And oddly enough, the information I'm providing you is from Answers in Genesis. So anyway, what happened was that there was an instrument that was built on the LBT. This is a camera. This is not a telescope. This is a camera. Large telescopes, again, large telescopes are really expensive, but they're built, even our telescope is built this way. You can build a telescope where you can have multiple ports that you can shine the light through. So for instance, with ours, we have a tertiary mirror. So we have literally a flat mirror that spins, and we can spin that flat mirror to direct the light either to an eyepiece for public viewing, our main research CCD camera, our new patron-funded planetary camera, and our new IR camera, which I have my doubts about. Hopefully my director is not watching me on this. So with professional grade telescopes, because they are so costly to make something that big, you want to be able to share it with as many investigators as you possibly can. Astronomers, when they do active research, you will often refer to them or hear them referred to as PIs, or principal investigators. And so an investigator will, at least the first one, will build their own camera specifically designed to do the science they want to do. And they get to name it. And they get to stick it on the camera, stick it on the telescope. They get preferential time with that instrument, but others can use it if their proposals are good enough or are seen to have merit. And they get to name them. So this is how cameras are named. Cameras are named, and they are put onto telescopes that also typically have names. So right off the bat, is the Vatican Observatory Telescope named Lucifer? No telescope has ever been called Lucifer at any point whatsoever. However, there was a camera where the PI thought it would be really cute to call it the large, with the L, binocular telescope near infrared spectroscopic utility with camera and integral field unit for extragalactic research. So L, and so they decided purposefully, not to include binocular telescope near infrared spectroscopic in the acronym. They only use large utility camera integral field extragalactic and research, so they could purposefully spell out Lucifer, because they knew that they were sharing the mountain with an instrument run by the Vatican Observatory. I don't know why. I didn't know why they thought this was a great idea. I don't know the people involved. All I can say is that this was a deliberate they wanted this thing to spell Lucifer in the worst possible way. This is what we call a backronym. So backronyms, so an acronym obviously is you take the first letter of the words involved and boom, you got an acronym. VAT, Vatican Advanced Telescope or Technology Telescope, VATT. Morning telescope, or have a good night, Stephanie. So that's, typical acronym. Astronomers are really, really boring with their acronyms. As noticed by the Large Binocular Telescope, the LBT. You have the Very Large Array, the VLA, the Very Long Baseline Interferometer, Very Long Baseline Array, VLBA, and the list goes on. Eventually, people kind of decided that they wanted to be a little bit more original with their naming, and so they tried to snazz things up a bit. And I can't think of any of them off the top of my head that are natural acronyms that are cool, but eventually they just gave up on that and they just started doing backronyms. So, for example, I had a prime example of it. Well, Lucifer is an example of that, but I'm trying to think of another one. And I'm blanking on them. There's a camera known as Minerva that has in the infrared. There is, Lord, I am really blanking on these names. They can get quite interesting. One of the cameras for wide survey is Assassin, of all things. I honestly don't remember what that stands for. But so this camera was named Lucifer, as you might expect. It didn't really go over well with certain folks, so they changed it. They shortened it to Lucy, which again isn't a great acronym because it basically uses the L, the U, the C, and the I, rather than the L, B, T, and I, S. Anyway, so that's the controversy. That's the story behind it. So was the Vatican Telescope named Lucifer? No. It is wrong on a couple of different levels. One, no telescope was ever named Lucifer. It was a camera that was given the acronym, purposefully given the acronym Lucifer. That camera was not attached to a telescope that the Vatican owned. It was attached to a telescope that was on the same mountain as a telescope that is run by the Vatican Observatory. So, yeah. So if we could stop with that little thing. I know, hey, the followers of Catholicos, they're evil people, they're papists, and, Lemaitre was a Satan worshiper who, when he came up with the Big Bang, all that, whatever. I know you want ammo for that. It just isn't here. Howdy, Judy and Dr. Nimrod. Speaking of acronyms and things, I think most of you who are in here right now are already have heard this, but like I said, many of these acronyms are strictly acronyms, but try to be as inventive with them as possible. Sometimes they're not even acronyms. So let me give the example of CHARA. CHARA is the interferometer that I use on Mount Wilson. CHARA stands for the Center for High Angular Resolution Astronomy. Pretty dull, right? Then you've got the first camera that was attached to the instrument. Basically, it's a test camera. It only combines a light from 2 of the 6 telescopes. Call it classic. The next camera, which can combine the light of 3 telescopes, that was referred to as, or is referred to as, CLIMB. I think that is an acronym, but it's been so long, and we just refer to it as CLIMB that I can't think of it. The next camera that was added was called MERC, and that's the camera that I primarily use, the Michigan Interferometer, or the Michigan Infrared Camera. real imaginative. John was not one to, he was not overly original in that. He didn't see the point in that. Interestingly enough, he named all of his servers after forests in the Lord of the Rings. So he and I had some wonderful discussions on the quality of Tolkien's work. So Merck. And then we had an Australian group. The PI for that was Mike Ireland. And he decided to name his camera Pavo, of all things. Again, I don't even know if it's an acronym. He decided to call it Pavo because of the constellation in the southern hemisphere, which is, I think, a turkey. Then you have Vega. The French have a instrument that's called Vega, which these are always in capital letters, so they tell me that they indicate that they are acronyms of some sort, but I, again, didn't even look into it. But, this is a common practice. It's so common that back in 2003, when I first got into grad school at Georgia State, I went in for a couple of years, had to leave because of financial reasons, and then came back later. So in 2003, the largest astronomical convention what came into our city, came to Atlanta, and that was the Winter AAS conference. AAS stands for the American Astronomical Society. AAS. So we decided we were going to create a poster for this conference, a joke poster. Posters, you might wonder what that is. Well, from an astronomical or from a academic standpoint, at least for astronomy, and I think physicists do this too, is that if you have a result that you want to publicize at a conference, and for whatever reason you don't want to talk about it, you don't want to give a 5-minute talk on it, you just kind of want to put it out there. Maybe your results are preliminary, or you're preliminary, or you just don't have the time invested. I don't know. Basically, you want to get the word out, but you don't want to talk. You don't want to give a talk about it and write a lecture or a conference letter about it. So you create a paper. My first poster is actually right behind the camera, and it's really, really, really showing its age. Anyway, and you set these up on boards in a fairly large conference hall, and people come in, mingle, wander around, look at your poster, ask you questions. Is this the main reason why we do all of that? It's not really to propagate science. It's networking. Almost exclusively, the people who are going to have posters up are either going to be undergrad or either going to be grad students or postdocs, maybe the occasional undergrad. And really what they're doing is that they're saying, hey, look at me, look at my work. You want to hire me, or you want to hire me when I get out of grad school, or I move on to my next postdoc or permanent position, hopefully a permanent position. It's all about the networking, baby. It's about shaking hands, talking with people, getting your name out there, getting your work out there. And that's the whole reason for it. Well, we decided that we were going to put out a joke poster. And we talked about the poster was about the building of the super huge interferometric telescope by the Astronomical Society of the South. Yes. So the acronym for the telescope is SHIT. The acronym for the association is ASS. And as you might imagine, the rest of the poster was along those themes. The objects that we were planning on studying were black holes, Uranus, gaseous phenomenon. So yeah, basically think grade school level humor, and you've got the crux of the poster. And yes, part of the motivation was to poke fun at the fact that, we deal with these acronyms all the time in our work, particularly when it comes to cameras and societies and telescopes and so forth. It was literally ripped down. Posters are typically tacked onto these boards that stand up. They didn't unpin it. They ripped it down. We apparently pissed off one of the organizers for this meeting so badly that they came personally to rip it off once they found out about it. I thought it was a bit of an overreaction, particularly since, this could easily be explained because frequently in bureaucracies, the left hand doesn't know what the right hand is doing. You have to submit even with posters, you have to submit the title of your poster and its abstract, basically a short summary of what your poster is saying. And we did not hide the fact that this was to publicize the super huge interferometric telescope being put forth by the Astronomical Society of the South. So someone presumably read that and said, okay, sure, why not? Joke posters are very rare, but ours was not the first one. So the fact that it was they butthurt, apparently they were butthurt. So yeah, I don't know. Astrophysicists have no imagination. Yeah, at least when it comes to naming, we certainly don't. I mean, dark matter that is not dark, or matter that is not light or not lit up. I mean, really dark? That's the best you could come up with? Dark energy that we can't see? Okay, sure, why not? Was the poster peer reviewed? No, it was not. And in a sort of serious way, I will say that no poster is ever peer reviewed. And when it comes to conference proceedings, so for example, I have an article in this. This is a conference proceedings. This is the resolving the future of astronomy with long baseline interferometry. These are also not peer reviewed. So if you give a talk at a conference, like the AAS meeting, then you are asked to write a article about that talk. And that article is not peer reviewed. It's just put out there. So it could be completely wrong. Probably isn't, but it certainly probably isn't completely right either. And so it is not peer reviewed. Join CT, Campaign to Eliminate Acronyms. I think I might become a card carrying member of CT if that's the case. Oh, and this stream is informally brought to you by Cherry Coke. Not my Coke of choice, but why the hell not? So yeah, that's all I'm going to say on the Vatican Telescope. Yada yada. So let's talk about a brief history of black holes. So the smell of the book is okay. I give that about 4 out of 5 stars. The feel of the book, not great. Feels cheap. I don't know who this publisher is, Pan Michelin. But one of the reasons why I love reading books as opposed to ebooks or audiobooks or listening to audiobooks is the tactile sensation, of having it in my hand and being able to flip the pages as I progress through it. There's just something inwardly satisfying about doing that. So the book itself is definitely something I pay attention to. And yes, I do smell books. Smells pretty good. It feels cheap. It's also smaller. It's also smaller in area than a typical library paperback. I don't know why. But it's all right. And the pages are also kind of a yellow. Not that should distract from anyone to read this book. It's just my observations of the quality of the publishing. Now, I've only read a very short portion of this book, but I've got comments. I've got a couple of comments. So the prologue is entitled "Standing on the Shoulder of Giants." Now, to begin with, as the title would describe, this is a brief history of black holes. This is a history of science book. So there is a little bit of explanation, from my understanding, from skimming it. There is a little bit of explanation as to the physics behind black holes, but the primary motivation, its thesis, is to describe how the ideas of black holes developed in a historical sense, or in a historical way. So, and hence the "Standing on the Shoulder of Giants," which is a quotation from the Principia, where Newton says that he, when, Brenda, if you're watching, I just got your notifications. So where was I going with this? "Standing on the Shoulder of Giants." It's written by Newton in his Principia. The idea is that he did not come up with his ideas whole cloth, but his physics is but a stepping stone. His is but work that is built on the foundation of scientists, giants, as it were. And so that's what she does. That's where that quotation comes from. But, and I find this notable because I'm also reading "A Pale Blue Dot" by Carl Sagan, which I'll talk about in a second. But in one of my previous, possibly the previous, Shouting into the Void, I was talking about how Sagan seems to go off at far too long about our own insignificance. He seems to, the implication is that our significance as a people is almost exclusively, if not exclusively, driven by a positional argument. We are not significant because we are not in the center of anything, which I wholly disagree with, and maybe some other time I will, because I know I Can Science that was disagreeing with me in the comment section, so maybe I'll do a stream or a video where I go into that a little bit more depth. But getting back to this, she does basically the same thing. She says, she talks about that we are rotating around and revolving around things at very high rates of speed. And she says, but that's not all. The sun is just one star in the Milky Way, our galaxy of over 100 billion stars. The sun is not unique, and it is not at the center. In fact, it's fairly average and unremarkable as stars go. The solar system is contained in a minor, see a pattern here? Her words, spiral arm of the Milky Way known as the Orion Arm. And the Milky Way itself is also a fairly generic, spiral-shaped island of stars, not too big, not too small. So my question is, why is this needed? It's all true. I'm not refuting anything that she has to say. But what is the point of this? It has nothing to do with black holes. I mean, she does tie it into the fact that there is a supermassive black hole within our own galaxy. At the center, that's what we're revolving around at a great rate of speed. But why is pointing out that the sun is not a superfluous star? Why point out that the Milky Way is not a superfluous galaxy? What is the point of that? Because it seems to, I'm inferring that she is trying to state that we are not significant. And the reason why I think that is because she directly talks about flat earthers. Quote, as someone who loves science history, it is both painful and curiously fascinating to watch the rise of, quote, flat earthers who claim the earth is flat. They insist that NASA and the US government, with all other space agencies and governments presumably in cahoots, have been perpetrating the lie of a spherical earth. What's interesting is that the thoughts and arguments they discuss among themselves are the very same ones that early Greek philosophers had thousands of years ago, but eventually discarded after more experiments and observations. And I'll go on a sec, but side note, oh yeah, I agree. Like, I actually accused sleeping warrior of being Aristotelian, and he did not like that for some reason. But yes, a lot of the arguments that I hear from Flat Earth are very similar to those put forward by early Greeks, particularly from a geocentric standpoint. Now, the Greeks, the Aristotle, and even Pythagoras put forth the idea that the Earth was a sphere geometrically. Aristotle put forth the idea that the Earth was a sphere due to observations and logic, boats going beyond the horizon and lunar eclipses. But besides that, the idea that we are central to things and all that kind of good stuff. Yes, a lot of things I hear from flat earthers are pretty much the same things I've read about coming from Greek astronomers. But anyway, she goes on. This is the crucial part that, quote, flat earthers struggle with, letting go of an argument that they are emotionally attached to when their experiments show them that the earth is not flat. They somehow cannot end their odyssey of confirmation bias. The society never progresses if it refuses to change its beliefs when presented with overwhelming evidence to the contrary. Now, again, I don't disagree with anything that she just wrote. The reason why I'm pointing it out is, why is it here? This is a brief history of black holes. She starts out with, she only spends a chapter or a paragraph on it. But the clear implication to me is she's basically saying that we are not in a privileged position. Now, I am tacking that on to Sagan, so I may be strawmanning her for this, but my inference from this is that she is by then saying that we are not significant, which when she brings up flat earth is one of the things that I hear a lot from people who believe in flat earth or science skepticism, is that modern astronomy tries to sell the narrative that we are insignificant, that we are a mote of dust in a vast cosmic void, and that we mean nothing. And I can see where they get that because of this. As a science communicator, either what we need to do is take the opposite tact, which if I ever did write a book, I would, or, and I think this is the better way, don't comment on it, particularly if it really has nothing to do with your thesis. Talking about the averageness or insignificance of or whatever of position of the Earth in the universe. What is the point of that? What are you attempting to get across? Because for my money, all it does is it will ostracize people. It will give people the impression that you are telling them that they are not worthy of anything. And for those of you, or for the rest of us, it adds nothing to the conversation. Like, okay, I already, well, obviously I'm an astronomer. I already know that the Earth is a mote of dust in a nearly infinite void. But, yeah, I'm like, why is this here? Why did she have to put that in there? I'm assuming the flat earther thing came in because she got her start on YouTube and still is on YouTube. So she has encountered this. But that was the main thing. And the other thing is, where is it? Let me see if I can get you an example of this. She also does, I think, another science communication no-no. And that is the reliability of science, or here's a part of it. She's talking about dark matter. She discusses that dark matter was not originally accepted, widely thought of as a thing, and was one of the most recent sort of developments that has had the most pushback. But she says that it came about after, and this is This is her talking to, say, a skeptic. It came about after over 3 decades worth of observations, and research pointed to no other plausible conclusion. Again, maybe I'm strawmanning these. Maybe I'm putting to put into it. When I read that, along with a couple other statements that she makes, is that she is essentially stating unequivocally that dark matter is fact, that science deals in facts. It doesn't. Ish. It deals with direct observations. It deals with observations, and then it deals with how to interpret those observations. Dark matter is currently the best explanation we have for things like spiral galaxy rotation rates, elliptical galaxy velocity dispersions, formation of galaxies, although that is becoming something of a question, which seems to go directly against this. So again, she is giving, at least to me, she's giving the impression that she is stating that science is irrefutable almost. That when we say that there's dark matter out there, then you need to believe us that there is dark matter out there, because there is absolutely dark matter. Again, I very well may be overstating this, but that is not the only time that she kind of implies that science knows absolutely what the universe is like. And I know there's an argument. Oh yeah, Zwicky came up with, it was in the 30s. I thought it was the 50s, but you would know better than I would. Zwicky is a fabulous dude. I don't know if I would go bar hopping with him, but the fact that he came up with the term spherical bastard and I don't know if he actually pulled a gun on one of his co-authors, but he certainly threatened to shoot him. So Zwicky was definitely fucking a character. I know that I've heard the argument that by emphasizing the inexactitude, I guess, for lack of a better word, of inexactitude of science, that science does not deal in absolutes, that is inviting people to not believe in science. That is inviting people to not take what we have to say seriously. And I get that argument. But I also get the argument that, again, very much, I practice radical honesty. These are if we want to be honest, then we cannot or should not put it out there that we know absolutely what the universe is like. Because if you talk to somebody in the 1850s, classical mechanics was how did you put it? The only plausible explanation. Yeah, but that, I suppose there is that, but it doesn't, but what needs to be stated afterward is that given the data that we currently have, that these explanations are subject to change. And I think one of the issues, and I don't know, and this is broad, one of the problems I see with a lot of discussions, particularly around science, where it comes to evolution, when it comes to Big Bang cosmology, when it comes to gender identity, there's absolutely no nuance from either side. One side says it's complete bullshit. The other side says, no, it's absolute fact. We need to introduce nuance to these conversations. I don't know how to do that well, I don't think. But I honestly think that it needs to be done, and it needs to be done. And yes, it's way easier to say that the universe is the matter in the universe is 85% dark matter, and just leave it at that. It's way easier to say that. But that's not absolute truth. That is really just our best guess at this point. It has substantial evidence to support it. I'm not saying it's not right. I'm not saying to be flippant about it, to say that it isn't. I'm not going the skeptic route of saying, well, we can't, because we are not absolutely certain, we have to throw it out the window. I'm not saying that at all, but I'm saying that nuance needs to be brought into the conversation. But again, it takes time, and those are much longer conversations than he had. And obviously, we don't really want to have those in comment sections of in YouTube or in Discord or what have you. But when it comes to science educators, science communicators, I think we have an obligation to enter into those conversations. Now, don't get me wrong. She's a lovely writer. The book is well written. It's entertaining, and I'm definitely planning on reading it again, or reading it all the way through, because my understanding of the history of black holes is not as much as I would like. So hence why I like her as a communicator, and like her style of communication, and she is obviously knowledgeable in this. So I said, hey, let me support her and buy the book and read it. But I did want to just get that off my chest. I did want to shout that into the void, that I'm disappointed that I read that, because I don't know what the point of it was. Because again, it's not tied to the thesis, and it does seem to indicate that what she's trying to say is, you skeptics need to shut the fuck up. We got all the evidence, you don't, and I can see the point behind that, but is that going to be effective? Or is that actually going to be counterproductive? The pale blue dot. Thankfully, Sagan has moved off of trying to convince us that we are not significant. Actually, he's kind of going the opposite route now. What the book is turning into, or has turned into in the mid chapters, is a discussion or a survey of the solar system as it was known at the time of the writing, which was 1995. He's talking about, and particularly with the angle of talking about habitability. So he talks about what it would be like to live on, or what kind of life could exist, or what kind of organic material exists on Titan, what kind of organic material exist on Triton, whether or not it's feasible to live on Venus. It isn't. And it's fascinating stuff, because I like Carl Sagan's work. He is one of the people who got me into this idea of science communication. I very much look up to Sagan. And I love Demon Haunted World. Fantastic book. Highly recommend everyone read it. So it reminded me of why because he puts passion into it. He's a very well-spoken or well-written dude. And it's positive. It's an inspirational message, which is what I think is needed. Particularly since I think the subtitle of the book is a inspiration for exploring the solar system, something like that. I can't remember what it is. So I'm happy about that. So I'm halfway through that book, and I'll keep you updated on where it goes from there. Because really, why I wanted to read the book was I was very familiar with the quotation. Actually, it's right there, where he describes the pale blue dot image, or talks poetically about the pale blue dot image. And I wanted to see what his vision of solar system exploration would look like. Again, this was back in 95. So at that point, it was published in 95. So more than likely it was written in 94. So at that point, he only knew of one exoplanet, and that was the pulsar system. So he didn't even know about 51 Peg B, which is, I would imagine, I really wish he were alive today, just simply because I think he would love just all of the new information we've gotten about exoplanets and things of that nature. I'm pretty sure he would be a kid in a candy store with this stuff. But anyway, so given the fact that it was written back in the mid 90s, obviously he didn't know what we know today, but I wanted to know what his philosophical viewpoint was on people expanding out into the solar system, because now that is, as I've said in previous streams, that is becoming more of a reality. That is becoming, I think that's becoming a certainty in the human species, is that we are definitely going to have lunar bases. I think it's pretty likely that we will have permanent installations on Mars. And who knows? I don't know about the rest. But I think those are definitely highly likely. Lunar bases are going to happen. I would place money that lunar bases are going to happen within my lifetime. Permanent installations where people come and go off the surface of the moon. That'll happen in my lifetime. Martian bases, if it does, groovy. I don't see it happening. I see it happening in the next generation. Those of you who have kids in their generation or in their lifespans, they are going to see Martian permanent. I think it's likely that they will see Martian installations where people come and go, or just live. Let's see here. So that's why I was reading that. And hopefully he gets into that near the end. Let's see what the comments have to say. I don't think you can write popular science books where every result is included with the sentence, the result is tentative, as is all of science. I'm not suggesting that you do that specifically. I'm not suggesting that you put in a result that after every sentence. What I would suggest if I were to write the book, I would, instead of writing about, the Earth being one of a multitude of worlds, yada yada yada, my preference would be about explaining how science is provisional and talking about everything that I'm going to talk about in the book. You need to take with the understanding that in 10 years, even, things could be completely different. And actually, she kind of states that in this one, where she talks about looking at a book called Modern Astrophysics, which was written in 1905. And in that book, they were talking about the fact that, the Andromeda Galaxy was just known as a nebulae, and the universe was only the size of the Milky Way galaxy. And she says that someone reading this book 100 years from now is probably going to be tickled by how antiquated the knowledge is. So I would lean harder, if I were going to make that kind of preface at all, I would lean harder into that. Or I would not make any statements about absolute certainty or most plausible or anything of that. I would just make declarative statements. That might seem contradictory to the idea that we shouldn't be saying that these things are fact, but if you just state the information without belaboring the point, without saying that this is the best, you shouldn't question this, I think is the way that I would go about doing it. So, I don't know. I don't know what her views on aliens are. Maybe I will ask her at some point. Let's see. It's weird reading Feynman work and having him just throw his hands up and say, we don't know what causes earthquakes. But at the time he was writing, that was true. Yeah. Magnets. How do they work? I love that interview on YouTube that can be found on YouTube, where I think the interview asked him, how do magnets work? And he just, I don't know. The first phrase that comes to mind is he dresses the man down. But he doesn't really do that. He just kind of says, that's a ridiculous question to ask. It's a ridiculous question for you to ask me and expect a simple answer, because that is not a simple question. How do magnets work is not a simple question. And the way he described why it was not a simple question is beautiful. I truly love that interview, or that section of the interview. And it reminded me of this because in part of that interview, if I remember correctly, he kind of does the same thing where he just kind of throws his hands up and says, we don't know about certain things. Basically, I think it was a quantum mechanical effect. He's like, we don't know. PhD Tony, he admires my optimism. Thank you. about the influence of climate change. I rather think the next few generations will have more urgent issues to deal with than Mars base. I think that the two are not mutually exclusive. One of the ways to mitigate the effects of climate change is to remove people. Is if you remove the burden of people on the earth. Now, that being said, if you're going to mitigate climate change that way, then you're going to have to remove a whole lot of people. And that's not going to happen with space exploration, not anytime soon. But I think it is a piece of it. I think that that is one of the tools that can be used, because obviously this is not climate change is not a one solution problem. There are going to be a number of different solutions put into place in order to mitigate, or just to make sure that we don't kill ourselves or destroy a massive amount of our population and go into the sixth mass extinction. And I think space exploration is one of those pieces. And I think we can do that alongside with implementing other results. Now, it's interesting that you say that I am optimistic about climate change. I am not. I am not, actually. And again, I think of this because of a discussion or a comment thing about with Vatican Science that I'm actually looking at. He suggested I look into something called levelized cost of electricity, which I have a website up, and I've now found a lot more papers that I could possibly even read on the subject. And he seems to think that the technology for getting us off fossil fuels is readily available and cheap. That is news to me. From everything else I've read and encountered, that is not the case. That the idea of switching, say, a developing country from fossil fuel based to electric, solar, and wind can be done cheaply and effectively. I have never encountered that. No one has ever said that, and actually they've said quite the opposite. So it was eye-opening to me that he has said it before, but he really doubled down on it recently, where the challenge is the challenge for developing countries is not cost of electricity. But again, I'm just looking into LOCO. Speaking of another acronym, LCOE, level cost of electricity. So I will keep as open mind as I possibly can when looking into that. But I am not optimistic about climate change, to be perfectly honest, because of the fact that humans suck. Specifically, humans are selfish, and we do not want to share our toys. And so when we do not want to help other nations. It comes down to nationalism. And this is another reason why I am an unabashed globalist. I believe I am all for cultures. I am all for having a preserved, people preserving their culture or what have you. But if it impedes the unification of the world, then no, I am not in favor of preserving cultures. If you gave me two options, if you gave me the two options of having a diversified nation or a diversified world of 190 some odd countries, each with their own pristine culture, yet not working together on any kind of global issue, or a single global entity with one homogenous culture, but can work towards solving global problems. That second one, every day of the week. And again, not apologetic about it. Culture does not trump survivability, and we are getting to the point with climate change and with other factors, space exploration, that that one nation does not have the authority the capacity or authority to do what is necessary to solve these problems. So, would you be happy to have the unification of the world under the CCP? That's an excellent question. If I wanted to be perfectly, to not be a hypocrite, I would say yes to that question. And from a principled point, yes, I would be. I think that would, again, if given the option of being unified under the Chinese government or being as we are now, I would choose being unified under the Chinese government. That being said, I do not want the global government to be a regime. I do not want it to be a totalitarian regime. I do not want it to be an autocracy. Obviously, I want this to be as democratic as is feasible. And actually, I don't even know if a republic, a world, maybe a globe may require the invention of a different type of government. I don't know if a federal democracy or a socialized democracy would work under such a huge population. I don't know. I'm not a political scientist, but no, I am Clive's found the answer. He will be the world emperor. Again, I want to support you in that. I do want to support you in that. But when you start saying that you're going to build space lasers to kill people, my ability to support you wanes, shall we say. And yes, it is a great compromise. Let's see. Yeah, that is precisely the CCP argument that everyone would be better off if they were allowed to repress. So maybe I'm not clear. Do I think that a global government should come about through oppression and tyranny? No, I do not. I think that I believe that a global government needs to come about voluntarily. Is that going to happen? No, which is why I am not optimistic, because people hold on to their cultures as if that is more important than having the world not come to an end for the human race. I can't get on board with that. Maybe it's because I'm an uncultured American swine, but no, I'm certainly not advocating that a global government be instilled through autocratic methods, or certainly tyranny, or the repression of peoples, or anything of that nature. I want it to be done democratically. I want it to be done as peacefully and equitably as possible. It's pie in the sky thinking. At the risk of repeating myself again, I don't think that's ever going to happen, but I do believe that it is the only way that we are going to solve climate change. Because if right now we are saying, the Chinese and the Americans are saying, yeah, we will definitely cut emissions. Sure. We don't. They don't. There's no mechanism by which to force us to do so. There's really no incentive to do so, particularly when no one else is doing it. And then you have the challenges of developing countries that don't have as much energy independence as the developed countries have. So, yes, yeah. Cultural inflexibility is part of the issue, but so is religious thought and magical thinking. People who think they can choose what they will or will not accept as fact. Yeah, and I agree with that. I agree with that. Any kind of, and I think that religion and culture are inexorably linked. Yes, I think that any sort of dogmatic viewpoint which prevents you from looking at the greater well-being of everyone is wrong, and it's a position that should not be taken. And yes, that's kind of a side. Well, no, actually, it's not. Although I've I am seeing less of absolute climate change denialism, and more so now that climate change is actually due to humanity. But yes, you still have the denialism. You still have denialism. You still have the idea that I can burn as much coal as I want to. I can roll coal in my truck as much as I want, and it's not going to kill off anything. And who cares about the spotted iguana or whatever species happens to be eradicated when the Earth gets warmer? Um, yeah, it's short-sighted. It's magical thinking. That also needs to be done away with. Now, I don't know, and that gets all tied into coming back to science communication. How do we best change people's minds? How do we best identify or inform folks that some of the things that they are thinking is magical thinking? Is that the idea that what we're observing isn't what we're observing? I don't know. I've been struggling with that since the beginning, and I don't have a good answer for it. Best answer I have so far is nuance. Is trying to add nuance in the conversation, trying to make sure that the person that I'm talking to feels heard, feels respected, that sort of thing. So you need to forget politicians when talking climate change. It's up to environmental science and engineers to fix the issue. Indy, yes, I think from a technological standpoint, that is definitely true. However, that technology has to be implemented. And the only way that it's going to be implemented is either through government or more than likely, or more specifically, corporations. And we all know how fun-loving and warm and empathetic corporations are when it comes to the betterment of human society. It would be nice if scientists and engineers could just go out and independently install new technologies, but sadly, they're going to have to work with governments and corporations, and they have other priorities. If we can figure out a way, I think that if you could figure out a way to come up with a new technology that was absolutely a moneymaker, then, yep, I think that would get implemented. And I think that would even and I think that would be implemented even through economic imperialism. I think that corporations would force it upon other countries so that they can make even more money off those countries. I think that's the only kind of way to do that. PhD Tony, what we need to do is overhaul the education system. Fully agree with that. The problem with that, well, a hurdle that I see with that is that there is no education system. Definitely not globally. We have, at the extreme end, there are countries that don't even want to have women read. So that's obviously something that needs to be that's an educational system that sucks. From a American standpoint, from my understanding, and I can be wrong, but from my understanding, and as I've said before, the curriculum, the way things are taught, is not nationally determined. It's not state determined. It's not even, it's not state determined. It's county determined. How things are taught, the curriculum, from my understanding, is approved at the smallest local level. Where I think the main thing, again, my globalist point of view, is it needs to be nationalized. Ultimately, it needs to be globalized. You need to have standards because 4 plus 4 equals 8, no matter where you are. The United States Civil War was fought because of slavery. And yes, slavery. There is an economic nuance in there, but I am not going to get into that right now. But yes, the American Civil War was fought over slavery. Doesn't matter where you are. Doesn't matter if you're in Texas, South Carolina, New York, California. That's why the war was fought. So this idea that localities should have a say in how things are taught is ludicrous to me. Um, the idea that, and I'm, the idea that parents should have a uh, powerful say on how their children are taught, I don't agree with either. I think that parents should be allowed to raise um, objections and then work within the system to solve that problem. But yeah, so I don't know. I agree. The educational system in countries needs to be definitely overhauled. But Bertrand Russell about the 4+4 thing, he has some thoughts. Remind me who Bertrand Russell is. That the name is familiar, but I don't. It doesn't. It's not popping any bells. People can't drive standards. People can't drive anymore. Too many pedals. Yeah, I really wish they would make stick shifts in this country. I always felt that driving an automatic was driving a go-kart. But related to climate change, I will say that the way that I drive a stick is way less economically or fuel efficient than if it was just an automatic. I don't know if it's because I'm a lead foot or where I'm shifting, but I use a lot more gas in a standard with a standard transmission than an automatic one. Bertrand Russell was a famous philosopher and mathematician. He did a lot of work on set theory and logic. Thought he was a mathematician. All right. National exams and a curriculum would establish a standard for entry into higher education. Yes, I agree. I think that yeah, national exams in the States, pretty sure that's what we have. We have the SAT, we have the ACT, although there is the level at which those are looked at, I believe, is changing. And again, that's not nationally. The weight that people are putting on standardized tests are now at the university level. The university is now setting policies as to how those scores should be treated or how much weight they should be treated. So again, not a standardized system. Curriculum, no way that is standardized anywhere in this country. And maybe that's your point, and maybe that's Tony's point. But yeah, it at the very least, curriculum needs to be standardized across all localities. Because if we want, and this is tying back to another discussion I was having, which is diversity in academia. If we truly want to have the ability to make academia a true meritocracy, then you need to be able to level the playing field. And the best way to do, or one of the ways that needs, or one thing that needs to change or needs to happen in order to make that occur is curriculum across localities needs to be standardized, and the resources that are given to these localities also needs to be standardized. If you go to school in bumblefuck nowhere, Missouri, you should get the same quality of education from a technological and personnel curriculum standpoint than if you go to school in upstate Connecticut. But is that the case here? Hell no. Hell no. Howdy Alf, I haven't said it. Motorcycle has 6. Manual transmission. Truck is 18. Manual? 8. Are you shifting every 5 seconds? That's just too many. No. I thought 6 was too many. Like, holy crud. All right. Well, so yeah, that's my thoughts on the state of education, and that can, like I said, that could be. I would love to have a conversation among, like a voice conversation with you, Clive, and others actually on a lot of topics, to be honest with you. But the one that I really want to do is, thoughts on scientific method and how it's how it's implemented across other fields. But I also would like to have an honest conversation um, about how what needs to be done with our education systems across multiple countries, and how this relates to science skepticism. Because I have seen research where education is actually not the problem. It's not the educational system that is failing, because some of the skeptics can be told and can be taught the current view, and they can understand it. They just won't accept it. So something else that's obviously coming to play when it comes to science skepticism, but that is beside the point. Besides the observation that you made, that our educational systems are becoming woefully inadequate, particularly in this day and age. Definitely here in the States, I am worried. My nationalism, if I'm going to pop into it, is my worry is that the Americans are going to really start falling down the ladder in terms of innovation. Actually, I am pro-immigrant, if only because it brings in smarter or better educated people. You know, that is my feeling, and I know that even I have a problem with myself saying that. That I'm not trying to say that Americans are dumb, and that our education system is complete shit, but I am saying that it's suffering, and if we don't do anything, then that is my fear, is that we will continue to do things. For example, what was done during COVID, uh, I have, I probably will have some very, very, what's the word I'm looking for? Unpopular opinions about how we handled education during the COVID crisis, because I am more on the right than I'm on the left when it comes to uh, teaching during COVID. I understand the risks involved with having in-class students, but distance learning, and I want to find direct evidence of this, but my feeling, my magic feeling maybe, is that has done a great disservice to the education of folks. Is that I do not think people learn nearly as well left to their own devices in a virtual situation. Now, that being said, should they be all stuffed in the same room? No, obviously that would just perpetuate the problem. But there had to have been some other way. Granted, we didn't have a lot of time to develop one, but it didn't seem like anyone was trying to. I mean, we were locked down for what? In the States, we were locked down for a year. I don't even remember what the official lockdowns were, particularly in schools. You're telling me in a year they didn't come up with something better than learn through Zoom? Question, Chris Durham. Question: would the huge or quote unquote significant stars put out as so much radiation that it would be difficult to have a Goldilocks zone where life can thrive? Excellent question. So the habitable zone, and I will what's the word I'm looking for? I will spare you all my typical rant about how I think the habitable zone is a bullshit metric, but the habitable zone changes based on the luminosity of the star, how much energy the star puts out. And it does so in two ways. A low luminosity star, a star with a surface temperature, say 35 to 4,000 Kelvin, is going to have a habitable zone which is far closer to the host star, typically well within the orbit of Mercury, and it's not going to be very wide. The span of orbits going outward is not going to be as high as, say, if it were around the sun. You have, the habitable zone, hand wavily speaking, the first order can be thought of as extending just beyond the Venusian orbit and just prior to Mars. Depends on which model you're looking at, but effectively that's the case. So that span is the width of the habitable zone for a sun-like star. If you get to high mass stars, high luminosity stars like O stars that are, that have surface temperatures of 40,000 Kelvin, to give you a sense, the sun has a surface temperature of roughly 5,900 Kelvin. When you get to those stars that have tens of thousands of Kelvin, the habitable zone is way farther out, and it is much wider. So in terms of the chances of habitable planets being around massive stars, that is a active question of research. It's definitely possible, but it's not a simple question, because what you have to consider is where are the volatile materials, where are the rocks, where are the metals, where are the water, where's the water vapor, things of that nature. At least in terms of how we believe planets are formed right now, these are considerations that need to be thought of. Like, what does the circumstellar disk look like in terms of its temperature profile, its compositional profile for these higher mass stars, so that these, say a habitable planet or even habitable moon could potentially exist there. Incidentally, a friend of mine, he did a graduate thesis on looking at which stars, if you were strictly looking at trying to find planets in the habitable zone, which type of star should you look at? Now, from a certain of the two considerations are, or the two things to look at are, where is the habitable zone located, and really how big is it? How big is it? If you have a larger habitable zone, naively you would think you would find more planets in it. The issue is, it's the opposite. The coolest star, if you were trying to find the most stars in the habitable zone of a star, then you want to look at cool stars. And that is why when you look at exoplanet research, the first wave of exoplanet research was to look at sun-like stars, which are G-type stars, F-type stars, and K-type stars. Basically, stars that are a little hotter than the sun, stars that are a little cooler than the sun. They are sun-like. It's a very kludgy definition. Then it was determined that, so M stars there are a lot of them. There are a lot more M stars out there than there are anything else. The number of stars is preferentially to the low end. The lower the mass, the more of them you find. And so if you look at the area, the total area of habitability around a particular type of star, M's are way more has a way larger area than, say, an O or a B-type star. But Dr. Nimrod, hopefully you found this entertaining. And I will get to that in a moment. So, just to finish off the thought of habitability on planets, where was I going with this? Habitable zones, M types. Oh, the problem with, and this kind of goes into my rant of habitability, is yes, you're going to find more planets in the habitable zone than you are in M-type stars than you're going to in sun-like stars or higher mass stars. The issue then becomes, what type of planet are you finding in those habitable zones? You're going to find terrestrial planets for a couple of different reasons that I can think of off the top of my head. Main one is the amount of material. So in order to get a Jupiter mass planet that close to a host star, you have to have enough material to build it to begin with, and then you have to have enough material to cause it to be able to migrate inward from where it formed. With an M star or low mass star, is the disk massive enough? Does it have enough gas and dust in order to do both of those things? I'm not convinced. I don't think anyone's convinced. So you're going to find terrestrial planets there. Almost, that's a no-brainer. But you're going to find terrestrial planets that are what we call synchronously locked. Gravity is going to have frozen them into a certain position such that their rotations are exactly equal to their orbital periods. So they will be like our moon. They will only present a single face to the sun or to their star at any time. Generally, to first order. There probably is going to be a little bit of wobbling like there is with our moon, but to first order, only one hemisphere is going to see light. The other one is going to see day. In order to have a day-night cycle, you literally have to walk around the world. TRAPPIST-1 is a great example of this. There are like, I want to say six planets, 6 known planets in that system, 4 of which are in the habitable zone. Might be 3, depending on how you classify the habitable zone. All of them are synchronously locked. From what little I know of biology is you need a diurnal cycle in order for life to proliferate. That I could be very wrong about that. And also that's, even if I am, that's just data point of 1. So how habitable is that world? And then you can get into whether or not the star itself is amenable to supporting life. But like I said, I am 2 hours into this. I do have some more work that I need to finish off tonight, so I won't be going for too much longer. I've talked about exoplanets quite a lot, and so I wanted to kind of branch off into other topics. But I would be happy to create some kind of content that's a little bit more rigorous in terms of addressing this concept of this question of life in other worlds. So. Diurnal cycles need to be in a container. Truer words have never been spoken. It's just what does right and left mean to COVID? All right, for in the States, what that means is the right wing believes in individual freedoms trump personal safety or personal health. So it is more important for a person to be able to move about in any way that they want to, as opposed to safeguarding the people that are that they encounter. On the left, the opposite is true. Safeguarding of the society is trumps individual freedoms. And of course, how much those two weigh against each other, because obviously this is not a binary issue, to me determines your length on the scale. I think this country went far more left than it needed to. But I was told that was masks and social distancing and all that. That's where the science was pointing. So I didn't quibble. And I didn't quibble. I followed their recommendations as they stated them. The issue becomes, or where I become more right, is one of the problems I have with the political left is that they are not interested in nuance. But maybe this is true. This is probably true of all political entities, but it's like, we need to lock people down, period, regardless of really looking at it, except for essential people like, fast food workers. They can die. We don't care. It's an all or nothing sort of thing. So there was no, at least from where I was sitting, at least I did not find any evidence that people were attempting, because the mental health crisis is demonstrably worse now post-COVID than it was prior to COVID, because a lot of people found out what it's like to be isolated and how much that is detrimental to one's mental health. And one of the things and how that affects me is that prior to COVID, I could see a therapist twice a week. I'm lucky to be able to see a therapist once a month because of the demand, the sheer demand of therapy these days because of COVID. Now, that's another topic entirely. But my point is that there were detrimental aspects of lockdown, economic, health, educational, and there was no nuance to it. The left basically just said, "Fuck it, lock it down. That's it. That's all we need." And then the right was like, "No, open it up." Like, there's got to be something in the middle. There's got to be some way of accommodating the two. One of the things I really want to look at is looking at the statistics of excess death in Florida with respect to other states, because DeSantis touted that he was the freest of the states, and I want to see whether or not the data actually shows whether or not his policies led to excessive deaths, and if so, how much excessive deaths. This is obviously a way more complicated question, but from a philosophical point of view, I would say that I'm more right on this than left, in the sense that I thought that we locked down too much. I think that we went too far to the preserving life aspect of things than we did to the preserving the health and educational quality of people. So that would be my personal point of view. Good night, Indy, and thank you again for being a patron and the super chat tonight. In the UK, the policies adopted by the UK government and the devoted administrations were essentially identical. They took the scientific advice, although some were left-wing and some were right. You could say the same thing in the States, but you definitely had a lot of people on the right who, well, actually, I would say almost exclusively the naysayers, the ones who did not want to take scientific advice, were from the right. Because again, their ability to get a haircut trumped the possibility of killing off your hairdresser. How essential do you think magnetic fields are? How important is the fact Earth has a large satellite that moderates our tilt? Magnetic fields are vastly important in terms of habitability, and this is something that I would definitely get into. Magnetic fields are, so you would need to have, if a world is, any definition of habitability is going to have to involve geologic activity, some discussion of, or some measure of geologic activity. Because if the world is geologically dead, then at least within our own solar system, that tells us that the magnetic fields are not nearly robust enough to be able to shield against high energy radiation. Now, Mars, you don't need a whole lot of shielding on it, even though its atmosphere is fairly tenuous, but that is mainly because I think it's so far away from the sun. On the other hand, Europa and Io, the moons of Ganymede, or the moons of Jupiter, you need vast amounts of shielding because of the vast amounts of radiation that Jupiter's putting out. And those worlds really have very tenuous magnetic fields. So a robust magnetic field is a necessity for life, as far as I'm aware. In terms of the stabilization of the tilt, I would say for the possibility of developed intelligent life, definitely a large moon is necessary to stabilize the tilt. Because if you don't, then your climate, we have natural climate change. The climate goes through the Earth goes through periods of glaciation in the geologic recent epochs. You also had the snowball Earth, the climate in the very early stages of the universe, in the Archean era. Obviously way different than it is now. But in terms of actual tilt, we have glaciating periods, and you can definitely correct me if I'm wrong. The periods of glaciation are on the order of hundreds of thousands of years. if our axial tilt were not stable, or were like Mars, such that it could vary between 0 to 60, then my intuition is that the climate change would be so extreme that life could not develop. Life could exist, but it would either take a much longer time for developed life to evolve, because it would have to shelter itself from such extreme climates over such a relatively short period of time, or it wouldn't evolve at all. It wouldn't develop at all. It would start to develop, and then it would get too cold, or it would get too hot, and it would eradicate that, and only the simplest organisms that are not nearly as adapted or not nearly as sensitive to such temperature extremes could survive. Again, not a biologist. This is simply my naive perspective that a large moon is almost a necessity for intelligent, developed life, which is one of the other reasons why I am so pessimistic about alien life on other worlds. Because our moon, I wouldn't call it a fluke, but it certainly isn't a natural, or it certainly isn't a ubiquitous thing to do or happen. Having a Mars-sized impactor smack into us and knock off a whole bunch of material, form an accretion disk from which the moon forms, I can't imagine that's a real common occurrence. But again, I'm working on a data point of 1, so who knows? Let's see. In Australia, we had pretty severe lockdown. We now have the second highest life expectancy rate in the world. Okay. Is that solely due to the lockdown, or is it due to other factors? Nuance absolutely does not matter. During COVID, the U.S.'s life expectancy fell by 2 years in 2 years. I'm not refuting that. What I would be interested in seeing is that statistic as a function of a lockdown metric. Say, for instance, how long were people prevented from going to hairdressers? That's the thing that seems to come into my mind. Yes, see whether or not how that data is correlated with that. I suspect that lockdown saved lives. I do not expect that to be any different. I expect that lockdown saved lives. My concern is that lockdown was the only tool to stop the spread of disease, and that all other quality of life factors were effectively ignored, in my opinion. Now, does life trump quality of life? Absolutely. Absolutely. I would rather have people alive and poorly educated than dead, because you can't be dead and highly educated. It was the issue that I have is, was lockdown and only lockdown the best course of action? I don't know, because like I said, I'm looking at how mental health has, for instance, the rate of suicide has gone up in this country markedly since COVID. The strain on the mental health system has definitely increased because of people's need to do that. I need to look into the data on the education system, but I would not be surprised to find that the lockdown or the virtual learning has made a significant impact on that as well. So that would be it. That would be why I was saying that. Battle Station could recycle planets and create new moons, as we did to Alderaan. Again, you're saying the quiet parts out loud. This is why I don't know if I have a lot of faith in you becoming the emperor of the world. But, hindsight is a wonderful thing, but we can only expect people to make decisions based on the information they have available at the time. true, and I fully admit this is backseat driving, Monday quarterbacking. That's what they call it, Monday morning quarterbacking. But even at the time, I felt that not enough was being done to look into these issues. It was, and again, I am maybe overestimating humanity's capacity to chew gum and walk at the same time. I mean, we had in the States a hard enough problem getting people to actually wear masks. So trying to come up with a more complicated system is probably asking too much. But again, I want to reiterate that I want people alive, and more than I want people educated. I am not saying that what we did was, if we're going to do it all over again, I would certainly want lockdowns to occur rather than not having lockdowns at all. What the thing I'm saying is that I would have liked to have seen a more, the word of the day is nuance. I would have liked to have seen a more targeted, more complex lockdown solution than we saw or than was implemented, because a lot of the lockdown procedures were the same based on population density. That seems to be that doesn't seem to be correct to me. If you have a population density that is less than the population density, if you have an area that has a lesser population density than another area, should the lockdown be as severe there than it is in a tighter one? Again, these are all specifications. I'm not doing a Fox News. I am not stating something by asking a question. I am not stating that the lockdown in a less population density area is in fact different than a higher population area. I'm not pulling a Tucker Carlson here. What I'm asking an honest question, and what I saw was those questions not being asked. But again, it was all very relatively quick. And like I said, in this country, we could not even agree to wear a freaking mask. Good night, Judy. Thank you for being here. And I really appreciate it. Anyway, yeah, I've been going for 2 hours and 12 minutes. Thank you all for being here. I think I'm going to shut down the stream. I appreciate all of you for who have watched and been here. Again, I appreciate the super chat that was given. And for those of you who watch this in the future, thank you for watching and supporting the channel in any way that you can. Please like, share, and subscribe. And because I'm a chaotic sumbitch, hit that bell for notifications, because I do not put out anything regularly. So if you want to be notified when I go live, then please hit that bell. That would be phantasmal or something. It's getting late. And all opinions are my own. So, and hopefully I will not be judged too harshly by them. But if I am, I will certainly hear about it in my comment section. And yeah, so good night. Clive, if you want compliance of a lockdown, you do need to make it feel equitable, otherwise it will be hard. Yeah. All right. Yeah. So time for the outro. Bellywood, if you watch this, I still haven't gotten time to change the outro to include you as a channel member, but it is on my to-do list. Peace out. Clear skies.